You get some interesting IoT crap on sale and you want to see what's in it, or maybe someone gave you one of these, you don't really want a listening device in your home. Well, the good news is that you can do a lot of fun seeing how they're built and doing some reverse engineering. So I'm going to take you through a few devices I picked up. The first one's this Echo Dot. So this is, Amazon's latest smart whatever device. And so normally if you want to take a look at something, the first thing you do is you could Google if there's a teardown already of it, and I think this one there might be. I don't even remember now. But one of the tricks to always look out for is, as soon as you get this FCC ID, which you can sometimes find without even opening the box, or sometimes not without even buying the device, it's in the manual or photos, we can go ahead and plug that into a website. So if we write this down, what is this guy? Go ahead and look at that. So I just Googled it. But what you want to do is you can use this website, fccid.io, fcc.io, or the real FCC website. This one has some ads on it because I don't have ad blocker on this demo version here, demo computer. Anyway, what you want is, where is it? Internal photos. There you go. So photo internal. And this is going to give you photos of the device. They have to submit it as part of anything with a radio. So if it has a radio receiver, if you have something that doesn't have a radio in it, then you're not going to necessarily see these. But if it has a radio, then we can definitely get away with using these photos to check it out. So, we can look in, and it depends how much detail you get, whether there's anything good. So we're probably most curious about the main board here. And oh man, so it looks like they've blurred. If you look at these, like these photos, I think they've purposely obscured the part numbers. And I don't know if there's some stuff missing in here. It looks a little suspicious, that area too. Because if we look, let's look at another photo, right? Like this is pretty good quality. You can read some stuff on it. So we might have to tear this down to get anything useful out of it, but that's always step one, is to check out the photos from it. So okay, that's going to be a no-go. Basically, we're going to have to go a little further. So if you from those FCC ID photos, you can sometimes get some useful information for the opening aspect. So if I go back to them here, we can see like there's clearly 4 screws somewhere. But that's not visible on the bottom. So what we would suspect is we'll just go ahead and try to like pry. There's like this rubber crap on it. So I'm just going to assume this kind of pries off. Just sort of glued. Take a knife around it. Okay. There we go. So there. So right away you can see some test points here, and then the 4 torque screws. So let's just open these torque screws. Torques. Driver. By the way, so for the tools right now, all I'm using, these are just like I don't know, if you get one of these cell phone repair kits that comes with a bunch of tools. Okay, so then this, I guess the lid just pops off. Interestingly, so this, I don't know if this is anti-theft or something. There's a little tag in the bottom, or part of manufacturing. But we're not going to worry about that because it has no connections to anything else. All right, so here's the main board. So we can see right away. Zoom in a little here. Okay. The test pads right here that are visible through the enclosure. And now we've actually got a bunch more test pads. So what would be a nice step 0 would be to get an idea of like a serial boot or something like that. So to do this, what I'm going to do, I'm just going to use a scope and probe some of these pads to get an idea. So the other thing would be nice to have would be a ground connection. So to do that, I'm going to kind of use a board I've got kicking around here from another video. You wouldn't necessarily normally do this, but I have this this board. So I just have a board that's actually used for some of my side channel work. You don't need anything like that, but what I am going to do is I'm basically going to put a ground connection under one of these pads here. It's a convenient one. Maybe this way actually would be easier. That's another Torx bit. Okay, it's the same size. Okay, there we go. And now I've got a easy ground. So then I can kind of probe a lot easier without having to worry about the ground side. And this guy uses a little power plug like this, so I think it'll talk to me. So now that this is grounded, basically this ground, I can connect my scope ground to this board ground and then just probe freely. So we'll open the Pico Scope software. Scope software is connected. I just had to switch my USB cable. So we'll use a 10 times probe. So we normally use the 10 times probe just because it gives us a much better frequency response, higher frequency response. I'm just going to put a trigger. So I'm going to use a trigger mode where if there's any toggling, it'll be a little more obvious. And all we're going to do is I'm just going to try different test points like this while power cycling the device. So we can see high. So ideally what I'd like to see is some like boot messages would be interesting. Now some of them could have, there can be stuff like it needs pull-ups or things like that on it. So this is just going to be a really fast test. Oh, that's like 12 volts out. Ones over here, there was nothing on them. That was just the ones I had on the screen. Oh, it's going to start talking, I think. So let's see. So there's two more over here. I'm just going to kind of go through the board. If they're in pairs together, that's not a bad sign. Let's see if this guy does anything. So this goes up to 1.8 volts, so it's not a 3.3 volt signal, whatever it is, but nothing there. And what's this guy? Oh, cool. Okay, so here you can see a whole bunch of data going across. So where I am is I'm right over here. So this test pad is clearly something. What we need to do is I want to go back. So in the software, if I didn't wait too long, okay, it actually stores a bunch of these messages. And I don't know if I was sampling fast enough. But it seems like, let's see. So here seems to be the first burst. And if we measure the bit period here, 8.6-ish microseconds. So what you can do is you can invert that. Actually, it might even have this built in. So if we invert that, it'll, I thought there was a way. I thought there was an option to display frequency. I'm pretty sure there is, but we could just do this. So 1 divided by 0.000. So it's 8 microseconds, 8603. So this is probably 115. I didn't measure this perfectly, so a standard baud rate would be 115. Now, if I look at the next, that's not... Yeah, it switches to a different baud rate, right? Because you can see these transitions are much faster. So I'm going to increase my sample rate so that I can measure that a little more accurately. Let's redo this. And I'm just going to re-power cycle it. Okay, there we go. So there's the higher speed data. If we look back at the high speed data, right, we get a unlock. Okay. So this is 1 microsecond-ish, a little over 1. So that's going to be a little, that's really fast. That's a little under a megahertz baud rate. 1086. So 920, 810 roughly is the other baud rate. So it's a little weird, and it's all at 1.8 volts. So what we're going to do is we're going to see what the actual messages are. I could decode it on the scope, but it's easier in a terminal, especially if there's going to be a ton of data coming across. So I'm going to just connect my scope for a minute. So I'm going to use this micro UART. This micro UART has a translator, voltage translator, so it can run at different voltages. And so I have a little bit of a weird setup here. I'm not recommending this setup. To generate the 1.8 volts, I have this target board. This is normally used for my chip whisperer stuff, but as part of it, it just has a bunch of voltage regulators. So I can take 1.8 volts, and I can feed 1.8 volts here from this board over to, I mean, basically it's just going to another pin header that's then going to route to the input voltage of this guy. So this is now going to translate to 1.8 volts. I have the ground connected, which again also connects to the ground of this board. And finally, I have TX and RX. So RX is this blue wire here. And this blue wire is basically connecting to RX of the serial port. And then I have TX here. So we can try, I mean, what would be cool is if the TX is enabled. But first, we're just going to RX. And you should, I mean, you can get better holding jigs. But I don't have it here with me, so what we're going to do is I'm going to hold this like that in a minute, and I'm going to open a serial port on my computer. So I'm just going to use PuTTY in case there's any interesting boot messages that like assume you have a proper terminal attached, which sometimes they do. Otherwise, you could use like Termite or any other interface or any other terminal emulator. So this is COM22 115200. We're going to hold this on it. Wait, RX is TMS. Hold on it like that. Right, so I'm just holding it on lazily. And at the same point, I'm just going to plug in power. Oh, it might be that it doesn't like. There's a slight pull up on that serial data line. Okay, there we go. So what you can see is, remember it switched baud rate, so there's some initial messages. This is all it gives you initially. So there's some configuration. Let's just copy that. And then it says jump to bootloader. Okay. So then it's jumping to bootloader, and that's all we get. So let's check out the other one. Let's change this to, what did I say, like 920, 10, bam. And let's just clear out everything. And all I'm going to do is, again, TMS here, held on it like that, if you can see, and serial up, and we'll reboot. Okay, so we're getting a whole bunch of messages. And it basically runs until, so what you can see is there's a, so this is the whole boot message. So you can see there's a lot of stuff going across. Oops. So this is the old and incorrect stuff. So after it jumps to bootloader, it does some early setup. So this might be like early bootloader stuff. BSI, blah, blah, blah. It's then going to turn on. So this looks like it's starting to turn on DRAM. So this is all pretty early stuff here. And what else is it turning on? Yeah, DRAM. So this all looks like early NAND setup. Okay, there we go. So we can notice there's a few things here that are kind of interesting. Okay, wait sync time 150 milliseconds to 5. So it's possible there's a way to enter a special mode. You can see it looks like it's saying you only have either 150 or 5 milliseconds. Like it's looking like it's a super short timeout on trying to enter that mode. If this is true, if this is actually a way to enter it. You can also see here it's saying that there's some magic value that tells it to boot, probably. So boot control magic, slot 0, so there's some different slots. So it successfully booted once. There's a second slot, so this might be like a backup or something, slot that it could boot if the main flash is corrupted. From there, it's now going to jump to the actual, see, somewhere we should see it jump to a kernel. And anti-rollback. So you can see it has some fuse settings that have passed checks. So it does have some anti-rollback protection, presumably. And it's now booting. So that's I mean, from a security perspective, seems pretty good. It's at least talking about setting this stuff up. Okay, and now we're booting. So it's some Android system. There we go. So you can see some Android boot stuff. We could see the boot command lines. And yeah, so that's about all here. Unfortunately, so what we're going to see eventually, there's an interesting message. I don't know how critical this is, but about the debug kernel. What eventually happens is that the console is disabled. So you see this note, boot console UART 0 is disabled, and it's switching to this TTY MT0 device, I suspect. But that's why this is the last message you get before it dies. So what we can try is we could try actually doing like if you send messages to enter the bootloader mode, we might be able to get into the recovery mode. Let's try that quickly and see if that works. So for this, what I'm going to do is I'm just going to like hold the enter button down. At the same point, I'm going to attach both of the transmit and receive. So it's a little hard to see because it's under my fingers, but I'm just touching both of those pads. And then I'm just going to plug it in. So if you remember from before, basically, yeah, nothing. And it's also not echoing, so I'm trying to hit enter right now as it boots. So if you saw from before, it was relatively late that it was checking for like a the UART, however that works. So you could see it go by quickly. What I suspect, actually, let's see. So if I spam, say, the enter key, will it detect anything? Or let's try the A key. Because we do see there was a point when it said, like, checking, blah, blah, blah. Okay, that's fair enough. So if I go back up here, did it even detect him? Like, is it looking for a magic value that I don't have is the question. BL, where is it? So it was somewhere up here. There we go. No, so you can say UART received data. Nothing received, so yeah. Okay, so anyway, so that's something to explore a little more. I might be the case, so my suspicion is that if you kind of spam it really fast with sending data, you might be able to enter a bootloader mode. I don't know what that means. It doesn't seem to be U-boot or something standard, but it's worth checking out. So let's just take a look at what else is on this, because remember those pins that had how they kind of were trying to trick us and hide away the details of this device. Let's just go a little further down the rabbit hole. And all I'm going to do is remove few more of these screws. Come on. And hopefully get something interesting out of this. I'm kind of curious what the main device is, and then we can also look at what sort of flash memory is on this thing. Oops, and I should be paying attention because there's two different types of screws that are coming out. I don't know if I'll bother putting it back together, but in theory. Okay. There's one more screw here that was loose but not taken out. Okay, there we go. So there's a little ribbon cable here that maybe what I'll do is just remove that, so that I can more easily pop this up without worrying. Again, I'm not as worried about taking this thing back together, so if you want to not break it, you should probably be more careful. Okay, there we go. Okay, perfect. So here's the main board. So what's the rest of this? We don't really care. This whole thing, by the way, it's pretty strongly built. So you can see like it's some cast material. So it's sort of an interesting construction. But anyway, we don't really care about that. This is our interest here. So here's the main section that was hidden away on the FCC ID filings. Nicely, so there's a shield here. It looks like this shield is not soldered down. Originally, I thought that was going to be the case. But because it's not, it should be even easier to just pry it up. And why I say I don't think it is just because of those dimples along the side here. That's pretty common for like a shield that's just a press fit. Come on. Let's just use abuse really a flathead to see if we can get this out. Okay, yeah, there we go. So you can see that just kind of popping off there. Not a whole lot else of interest around here. So actually the board construction is sort of interesting because once I get this off, I'll show you. You'll notice like it's using tiny. So on the back side here, for example, if you look in, it looks really smooth, and it's got these tiny vias. So there's kind of like a design flex going on here. I don't even know if you can see them, but it's using tiny vias and like, these tiny 201s. When there's tons of space on the board, at least in that section. So I guess they just are standardizing on it. So can't complain too much. Oops. All right, so there's some pink crap over it. Come on. To reveal, what is this guy? Come on. So this is some heat stuff, so we don't, again, care too much if we're not running it for long times. There we go. So here's the main, let that focus in on you. There's the main devices. So one of these is going to be DRAM, and one's probably I don't know if you can zoom any further. That's the limit. So if I look at this, okay, so it's a MediaTek device. It's some MT. Let's see if I get a light on the side. You maybe can read that. So you can probably see MediaTek there. There you go. So MediaTek MT85, so that's kind of, this is roughly what you expect from this. We also have sort of the other two chips going on in here. One of these, I don't know which is which. It's going to be SRAM, and one is probably an eMMC because I don't see any other flash or anything like that on this device. So I suspect what's happening is, and U5 over there at the corner is definitely like a switcher. So you can see like a big inductor hanging off it. So what you've got is a eMMC that's actually serving as the flash memory that holds everything about it. So it's a little more annoying. If you wanted to read them, you could either take it off the board, but then you'd have to reball it or just sacrifice it, or try to find the pins that are connected to it and read them. There's kind of a black hat talk on that. But that would be moderately annoying to do that. So let's see. So yeah, now that we got this guy apart, the next thing will be to play a bit more with how we could actually access the boot mode. So what I suspect is that if you're fast with the if you're really fast with this, then you might be able to get it to enter the boot mode. Last thing to check is actually, if the whole thing boots without the rest of the stuff attached, it's just going to be a little easier because then I've got this board and I can clamp onto it and solder to it. So let's just try that quickly while we're here before I wrap this video up. So I'm just going to shove a ground wire in. This is going to be, kind of hold it down. That should be good enough. Come on. Okay, and if I hold that like that, this is going to be, let's just put a screw in the hole maybe. So all I'm trying to do is, we always need the ground connection, and because this guy's powered from a barrel jack, it's going to be floating relative to my computer. Otherwise, I wouldn't have to do this. And if you check the computer out while I power set this up, with any luck, it's going to give me... Okay, cool. So we get all of the standard boot messages. Let's see if it goes, and it looks like it goes to that mode. So, so that's nice because now I don't have to worry about. What's happening now? It might be rebooting because it doesn't detect. Let's see if that stays up. What might be happening is that other board, whatever is plugged in over the ribbon cable. I'm wondering if it doesn't see that. Yeah, there you go. So it's clearly panicking and rebooting. So if you want to do, you do need, I guess, whatever's on the other end of this ribbon cable. There's presumably some other stuff up there attached if you want it to boot properly. If all you need is the first stage bootloader stuff, then you don't have to deal with it. Complete the taking it apart. Let's see. Unfortunately, I think I need a real Torx driver. This is going to be too short to fit. Let's see if it'll fit at all. Okay, yeah. This will work. So all I'm doing is kind of shoving the bit down and not fully putting it in. Come on. It's the same. There we go. Again, it's just a little shorter than the rest of them. Come on. So what I'm going to guess is that some of the Wi-Fi stuff is up at the top, just to give it a better propagation, because this thing is so metal, like, so you can see how it's all cast metal, right? So trying to put the antenna on that other board's not going to work super well, I imagine. Okay, there we go. Okay, so here's the top board. Yeah, so there's the cable that goes between them. So if you have these attached, I think you basically have a fully working system again. Might as well pop this apart while we've got it. here. So conveniently, they use the 1 Torx for everything. Boom, boom. Okay, so there's your Amazon Echo Dot top part. I think this just pops out. Okay. There you go. So there's individual little buttons. You have various lights. They actually have different light mechanisms, so it's sort of interesting, right? Like these are 2 side LEDs here. It looks like this is like a presumably multicolor LED, and 2 of them just don't have anything. There's a missing something in the middle, some other optional part or variant or whatever. I don't know what that is for. And here's your main. Here's the main board. So you can clearly see antenna 1, antenna 2. This might just be diversity. Like they're both 2.4 gigahertz, so it either could be different stuff or you just have antenna diversity. What else can you immediately see on this? Yeah, I guess that's the main stuff. So underneath this, how are they doing the Wi-Fi? Because some of those MediaTek parts have like built-in Wi-Fi stuff, but I suspect either for whatever reason they didn't want to use one of those, or oops, that went flying. There you go. Okay, this looks like, what is this? Is this another MediaTek part? It is. So it's MediaTek parts all the way down. This guy, let's see if you can see that, MT7658. So the top part has another MediaTek part, MT5678. And how is that booted? T7658. Let's just look up what that is. MT7658. Okay, so this is only, if this is right. Come on. 7.6. Why do they have this weird landing? I don't see the exact one. Let's just see 6.8. Might be close enough. Okay, so this is just a radio chip. So that's why they've done it that way, or that's why we have that here. So this is just the radio chip. So in theory, if we go back to this board stack, we could get the entire functionality of this guy by just plugging in the cable here. Oops, come on. I need to see this, just make sure it's mated. Yep. Okay. So if you do these 2 things, you might want some tape because they'll definitely, short out. But yeah, in theory, if we do these 2 board stacks, I put like something in between them. There we go. This will give us a fully functioning, complete like Amazon, Echo Dot system that you could sort of play around with. So it's sort of fun because these are pretty, cheap devices, so you can pick one up easily. You might get one anyway for Christmas or something, and you don't want to use it. But if you basically pull them apart, you get these 2 boards. I showed you the 1 set of test points. There might be some other interesting stuff on it, and it can be sort of a fun way to play around with these devices if you want to sort of experiment. And the nice thing about this 2 board stack that I have here is when you were playing around with the whole device, the one super annoying feature was that there was a speaker. So I've removed the speaker from it. So I think it shouldn't be able to talk. I'm actually not sure how that's connected. It's a good question. Because okay, yeah, so you can see there's two pads here. This must be the speaker. The speaker connection goes through. So the audio design in this actually, as a side note, there's pretty intense. Like here's the speaker here, and I think behind it it's all like a big chamber, and you can see like there's even whatever this plastic chamber is. Looks like it connects through, so it seems like they've gone to a lot of work to optimize how much sound can come out of just a pretty small speaker from this device. But there you go. Hope you have enjoyed a little bit. If I get time, I might prod a little more at it, see if you can enter the bootloader mode by using like a Python or something to actually send data to that really fast. The other thing you could do is look for the incoming message. So you have to do it on a microcontroller. You can't do it from a computer due to the speed. But you could look for where it says, the debug message that it's configuring the UART, and then send it some different characters and see if it dumps down to debug console or not. But yeah, that's a quick sort of teardown on the Amazon, whatever this thing's called, Blink. No, Echo Dot. Sorry, Blink's the other stuff. And hope you enjoyed it.